Our first problem is going to be 3 1/3 times 7 1/7. So we are going to draw our area model. And split it into 4 pieces. We're going to write 3 1/3 across the top and 7 1/7 down the side. Then we're going to write small problems on the inside, just like we do with the area model, just like we practiced on the anchor chart. So we're going to have 7 times 3, 7 times 1/3, 1/7 times 3, 1/7 times 1/3. Then we're going to find the products. Well, we know how to multiply whole numbers. We know how to multiply whole numbers times fractions. And we know how to multiply fractions times fractions. So we go 7 times 3 is 21. 7 times 1/3, we change this into a fraction. We go 7 times 1 is 1. 1 times 3 is 3. We then convert this into a mixed number. 3 goes into 7 how many times? 3, 6, 9, so 2. 2 times 3 is 6. 7 minus 6 is 1/3. Then we go 1/7 times 3. We change this into a fraction. 1 times 3 is 3. 7 times 1 is 7. And then we go 1/7 times 1/3. We multiply straight across. We get 1 as our numerator and 21 as our denominator. Then we make sure that we are going to pull out all of these products and add them up. So we have 21 plus 2 1/3 plus 3/7 plus 1/21. Then we stop and we observe. Well, we observe that we cannot add unlike denominators, and these 3 mixed numbers and fractions have unlike denominators. Well, if you remember, we always look to this box right here. This is generally going to give us what our common denominator is. So we are going to change all the denominators. This last one, nothing happened to it, so we can actually just drop it down. Then we go, how do we get from 7 to 21? Well, we multiplied by 3. Golden rule says whatever we do to the denominator, we have to do to the numerator. 3 times 3 is 9. How did we get from 3 to 21? We multiplied by 7. Golden rule says whatever we do to the denominator, we have to do to the numerator. 1 times 7 is 7. Now we can add this. So we're going to add like terms. We're going to add our whole numbers, which is going to be 23. Then we're going to add our numerators over fractions, because one of our other golden rules is that we never add our denominator. So our denominator is not going to be 63. It's still going to be 21. So I'm going to go 9 plus 1 is 10 plus 7 is 17. Then I have an answer, so I need to stop and observe it. And what do I observe? Hopefully I have my math journal, since they got passed back, and I am going to observe that 17 is what kind of number? It is prime, and it does not go evenly into 21. Therefore, this is my championship answer. Our next problem is 5 3/7 times 6 2/5. So we are going to draw our area model. We're going to split this into 4 pieces. We're going to write 5 3/7, and we're going to write 6, and 2/5. Then, just like we do with our area multiplication problems, we write the baby problems, our non-negotiables, things that have to happen so we do not forget. Also, multiplying fractions and whole numbers and fractions, it's a lot easier to see them. So that's why we're going to do that. So we have 6 times 5. We have 6 times 3/7. We have 2/5 times 5. And we have 2/5 times 3/7. Now we're going to find the products of each one of these boxes and these problems. We go 6 times 5 is 30. We turn this into a fraction and we multiply straight across. 6 times 3 is 18. 1 times 7 is 7. We need to convert this into an improper fraction, or we need to convert it from an improper fraction to a mixed number. We think, how many times can 7 go into 18? 7, 14, 21. Oops, too big. So it can only go in there 2 times evenly. With how many left over? Well, 2 times 7 is 14. 18 minus 14 equals 4/7. Then we turn this into a whole number. We multiply straight across. 2 times 5 is 10. 5 times 1 is 5. We have to convert this from an improper to a mixed number. See how all of the things that we've been learning, have learned last year in 4th grade, learned so far up to this point, are all coming into play. That's why we practice those things, and that's why they're so important. We go, how many times can 5 go into 10? It can go in there 2 times evenly. Then we multiply our fractions. We go 2 times 3 is 6. 5 times 7 is 35. Then we're going to take all of the products and add them up. We go 30 plus 2 and 4/7 plus 2 plus 6 35ths. Well, we stop and we observe this. We're adding, which means that our denominators have to be the same. We have a mixed number and a fraction, and neither one of their denominators are the same. So we need to change them. If you remember, we always look to this fraction by fraction box, and we use that denominator because that means that 7 and 5 both go into it. So we're going to change it to 35ths. We didn't do anything to this last one, so we can just bring it on down. Then we stop and we think, how many times does 7 go into 35? 7 times 5. Golden rule of fractions says whatever we do to the denominator, we have to do to the numerator. 4 times 5 is 20. Now we can add this problem up. Well, we're going to add up like terms. So we're going to add up our wholes first. We have 2 plus 2 is 4. And plus 30 is 34. Then we're going to add up our fractions. We're not going to add our denominators because that's another golden rule. We never ever add or subtract our denominators. So we're going to drop down 35. We're going to go 20 plus 6 is 26. Well, I know that both of these numbers are not prime, but let's look at the factors of 26. We have 1. We know 2 goes in there because 2 goes into any number that ends in an even number. 3 doesn't go into there evenly. 4 doesn't go into there evenly. 5 doesn't go into there evenly. 6 doesn't go into there evenly. 7 doesn't go into there evenly. 8 doesn't go into there evenly. 9, 10, 11 doesn't. 12 doesn't. But 13 does. That's our baby rainbow. So 26 can't go into 35 because we know our factors for 35 are going to be 1, 5, 7, baby rainbow, 35. The only one that they share is 1. So this is our championship answer.